Hi, I'm Deepak Shivakumar.
And I'm Akash Goel.
Today we're going to talk about why software projects are moving from centralized to distributed version control systems. For this project, we are using the Notepad++ source code to perform our analysis. Notepad++ is a source code editor written in C++. More information can be found at their website. Source code is also available for download at the provided link. We will evaluate both Subversion and Git using the following set of operations. First, for Subversion. As we mentioned in our podcast, we faced a lot of issues while setting up the environment for Subversion using a standalone Apache web server and Tortoise SVN for Subversion. So we decided to install Visual SVN server as our choice for Subversion server. Visual SVN server is a complete Subversion server package which has all the required Subversion features and functionality. Installation is out of box and very quick. The tool provides a GUI that allows performing administrative activities such as setting up repositories, creating users and groups, manage SSL certificates, and has extensive logging capabilities. To download the Visual SVN server package, we can just click download, and the download will be complete in about 5 minutes. Installation also takes about 5 to 10 minutes to complete. To create a new user, we use the create user option where we can give the username and a password for that user. The user can change this password as and when he wants. To create a new group, we use the create group option, which gives us a flexibility of adding users as and when we want. Now that we have a user and a group, we can create a new repository. To create a new repository, we use the create new repository option and then give a name for that repository. Once we're done with that, we select what kind of folder structures we want to create within the repository. For now, we will create a repository with trunk, branches, and tags folders. Now, in order to provide a custom access control for that repository, we use custom permissions, wherein we set the group that can access this repository. Note that we are giving read and write access to this group. Once we click finish, the repository is created. Now we also want to have a separate release folder, so we create a new folder within the demo repository. Now in order to start development, we need to create a local repository. So what we do, we create 3 folders: bug fix, development, and release. We copy the URL where the server repository is located and then check it out at the development folder. Now this gives us a local repository where we can work on the project. Once the checkout is complete, we have a local repository where we can add our code and then use the check modification options to check which files are non-versioned within the project. Initially, when we add our code, none of the files are versioned, so it shows that it is non-versioned. We use the add command to add these files to the repository. So when we do that, the files that are added are only added to the tracker but not committed to the repository. So once the add operation is complete, the tracker keeps track of all the files that have been recently added. Once we are ready to commit, we use the SVN commit option and give a proper commit message to commit the code. The commit operation actually takes all the files that have been added in the tracker by the add command and then pushes all the content into the central repository. Once the commit operation is complete, the central repository contains the entire code that has been committed recently. So this allows any other team member to download the changes made by the developer and a commit made to the central repository through the checkout command. he could simply use the svn update command to pull those changes to his local repository. Now let's go towards branching and merging. Now let's talk about branching. In order to create a branch, we can use the branch command, point it to the appropriate branch folder where we want to create the branch, and then give an appropriate commit message. There we have created a new branch where we can work on new releases. Now in the bug fix branch, we want to work on subsequent versions of version 6.1, where we will commit code from version 6.11 to 6.18. Now we just create a separate folder where we check out the bug fix branch, that is branch version 6.1. Now this allows us to work on a separate branch for all the bug fixes, whereas we continue development for version 6.2 on development branch. At the end of validation of the branch, we want to merge that back into the development stream, so we use the merge command. Now we can use a fully recursive merge back into the development stream. When we run the merge command, we can get a lot of conflicts. So in order to resolve these conflicts, we get a lot of options with the Tortoise SVN tool. We can either use the local copy or use the repository's copy, or we can just edit the conflict. Now let's use the edit conflict option. When we use the edit conflict option, we get a remote file copy, we get the local file copy, and we get a merge file. So the merge file contains all the conflicts in the form of question marks, as we can see. Now here we can see that in the remote file there are two white spaces, whereas in the local file there is just one white space, which is highly irrelevant to the developer, but for the tool it's a difference. Now this is a false positive which we would like to avoid in practical cases, because it's just a matter of white space that is causing this difference. So in order to resolve this difference, we have to manually select the lines that are causing the conflict and then copy the entire text block into the final merged version. Once we save the file, we get an option to resolve the conflict. So we use the resolve button and then move on.
Now let us talk about these basic set of operations with Git. To install Git on the developer's machine, we need to execute this command. Now we already have this installed on our machines, and thus we need not reinstall it. But installation of Git is as standard as installing other packages in Linux. Next, we should talk about setting up a repository. For setting up a repository in Git, we need to perform two operations. Firstly, we need to create a local repository which will be the starting point of the development cycle. For this, we execute the git init command in the working directory, which initializes an empty Git repository in the current working directory. Now we shall create a repository on a remote hosting service. For this project, we will use NC State University's GitHub Enterprise account for setting up the remote repository. Every user is required to first have a GitHub account and sign into it. Once signed in, click on the Create New Repo account button and create a new remote repository. We also see that we can set visibility permissions for the repository and initialize a sample README. Next, click on the Create Repository and the repository will be created. Now we can see that there are a certain set of basic commands that are available for pushing a local repository onto this new local repository. Now we should add files to the repository. Once files have been created or modified, they are required to be committed to the local repository. To do this, we use the git add command, and we can specify the names of particular files that needed to be added to the staging area, or we can use the asterisk. We shall use the asterisk to add all of the files to the staging area. Now that all of the files have been added, they need to be committed, which can be done using the git commit -m command and specify a custom message for that particular commit. For this initial commit, we will use the message as version 6.1 commit. Once we have created the remote repository, now it is time to commit the files from the local repository and make them available to remote developers. To push the local repository, we need to create a remote towards the remote repository. This is done using the git remote add remote name repository URL command. Here, the remote name is the remote using which we can push or pull commits and updates to the remote repository. It is possible for a repository to have multiple remotes to the same remote repository. The repository URL can be obtained from the GitHub page of the created remote repository. On executing this, we have now created a remote towards the local repository, pointing towards the remote repository. Now we need to push these commits onto the remote repository. This is done using the git push remote name and branch name command. Here, origin is the remote name and master is the master branch in the remote repository where we are pushing the changes. Now we are required to log into the GitHub account so that the commit is associated with a particular user on GitHub. Now we shall talk about branch creation. To create a new branch in Git, we execute the git branch name command to create a new branch. Here we will choose B1 as the branch name. Once a branch has been created, we can switch to the branch B1 using the command git checkout branch name, where the branch name would be B1. Next, we need to perform some merging and conflict resolution. Over here, we are adding and committing version 618 to the branch B1 and committing those changes in that branch. Next, I am going to commit and add the changes of version 6.2 into the master branch of the local repository. It is time to merge the two branches. For merging, we need to switch to the branch master that needs to be merged. So now we are on branch master, and the merge needs to happen from branch B1. Thus we use the command git merge B1. Over here we see that merging has failed due to conflict that have arisen. To resolve the conflicts, we need to manually remove the conflicts by opening each file and resolving the conflicts, or use a GUI based merging tool. We will use a GUI based approach to effectively demonstrate the conflict resolution process in Git. The GUI tool that we will be using is called meld and can be invoked using the git merge tool command. Let us take an example of the conflict resolution on the changelog file of the two branches. Using the tool, we can visualize the conflicts that have taken place and easily resolve them. Over here, we can see the changes that have taken place. On the leftmost pane, we can see the changes and the conflicts from the local copy, which is on master branch, and on the rightmost pane we can see the changes and conflicts that have taken place on the branch B1. Now we save these changes, resolve the conflicts, and close the GUI tool. On closing the tool, we see that Git itself will recursively call the tool so that the next conflict that has taken place will. With this, we've come to the conclusion that Subversion is an easy to use tool and comes packed with a lot of powerful and intuitive tools. Also, Subversion has a small learning curve as compared to Git. On the other hand, Git is extremely powerful when it comes to branching, merging, and conflict resolution. Moreover, Git has the ability for allowing teams to work remotely in a distributed setup and incur reduced infrastructure and setup costs. Ultimately, the choice to using Subversion or Git lies completely with the project team and depend on whether the team is working in a closely lit environment or and the frequency of branching and merging operations. Thank you.